Hello, so welcome back. We're resuming where we left off in the middle of page 4 of our section 4 note packet, and we're now going to talk about decision errors, which are just types of errors that you could potentially make when conducting a hypothesis test. They don't have anything to do with like errors in calculation, um, but it's entirely possible to kind of do the hypothesis test correct all the way through, but still maybe incorrectly reject the null hypothesis or incorrectly fail to reject the null hypothesis. And so let's go ahead and make a table to kind of summarize these errors. And so on the columns of the table, we're going to put what our decision is. So either we're going to reject the null hypothesis, or we're going to fail to reject it. On the rows, we're going to put what the truth actually is. And so either the null hypothesis is true or it isn't. And so in our table, there's going to be a couple of like correct decisions. And so if the null hypothesis is true and we don't reject it, that would be a correct decision because we're not rejecting it and it turns out to be true. If the null hypothesis is false and we reject the null hypothesis, that's also a correct decision. And so these other two boxes are going to correspond to our two different types of errors. And so a type 1 error we're defining as when we make the decision to reject the null when the null is actually true. So let's see where that goes on our table. So we made the decision to reject the null, but the null is true, so type 1 error is going to go in this upper left-hand corner. Take a second to think what that would be in the multiple choice example. So remember, these were our two hypotheses. And so for this multiple choice example, that would be something like, well, we're making the decision to reject the null, so that means something like we conclude that the proportion is different than a third because we're rejecting this null hypothesis when it actually is equal to a third. So when the null hypothesis is actually true. A type 2 error is just going to be kind of the opposite of that. That's going to be if we fail to reject the null, when the null is actually false. So that's going to go in this bottom right-hand box in our table. In the multiple choice example, it might be something like maybe we find that there is no evidence that the proportion is different than a third. When the true proportion actually is different. All right, so keep in mind that we're only doing the hypothesis test because we don't know the truth. So we don't know the truth between the null and the alternative. And so this, in practice, we don't actually know. We only know the decision that we make through the data that we collect. As kind of a different example, sometimes statistical hypothesis testing is compared to the US court system. And so for anyone who's maybe not as familiar with the US court system, it kind of goes to say that you're innocent until proven guilty. And so in this setting, the null hypothesis is that the defendant is not guilty. And the alternative is that the defendant is guilty. So take a second to go ahead and pause the video and see if you could think about what a type 1 and type 2 error would be in this kind of courtroom setting. So even if you don't write anything down, try to think through what each one of these errors would be. Okay, did you pause the video? And so hopefully you were able to at least kind of think through these. In this case, a type 1 error would be concluding the defendant is guilty. So you're rejecting that null hypothesis when they are actually innocent or not guilty. Type 2 error is just the opposite. So this is just finding the defendant is not guilty when they actually committed the crime. All right, so these are two different types of errors you could make. You could put an innocent person in jail, or you could let someone go who actually did commit the crime. The significance level is something that indicates how often we make a type 1 error. So type 1 error, incorrectly rejecting the null hypothesis. This is commonly abbreviated as alpha, and it's commonly equal to 0.05. And so if you're kind of reading journal articles in your field, you'll often see the researcher specify a level for alpha. That's either 0.05 or 0.01 or 0.10. That is just corresponding to how often in their study they're making a type 1 error. If it's 0.05, then they would make it 5% of the time. So again, go ahead and pause the video and think about if we set the significance level, or this alpha, to be 0.01, how often would we be putting innocent people in prison? And then also think about, what do you think an appropriate significance level would be in this courtroom setting? All right, so for this first question, 1% of all guilty verdicts would have an innocent person put in jail. So if we specified our alpha to be 0.01, then that means 99% of all of our guilty verdicts, the person's actually guilty, we put them in jail, but in 1%, the person didn't actually do the crime and they still have to go to jail. For this second question, it's a little harder to say what an appropriate significance level would be in this setting. I mean, ideally it'd be 0, right? But if it was 0, then we'd never put anyone in prison at all. So that's the only way that we could really guarantee that no innocent person ever has to go to jail. And so it's going to be different for everyone, but we're just going to make a note that decreasing alpha will result in more type 2 errors. So as you're decreasing alpha, you're putting less and less innocent people in prison, but just by definition, you're also making more of these type 2 errors, so you're letting people go when they actually did commit the crime. This is just, the purpose of this is to just think about this as being kind of a trade-off between these two types of errors and what you set alpha as. Okay, so we will pick up with our kind of last missed topic in the next video. As always, let me know if you have any questions.